All right, swap papers. All right, so for number 1, did you guys get 64 and 2? So you got 8 root 2. Look at us go. If they got it right, give them a check. If they didn't get it wrong, don't put anything. If they did get it, you know what I mean, guys. All right, number 2, you should have gotten 5 root 6. Number 3, you should have gotten 7 root 5, and I think we did those yesterday together. Then why did I do them on my, maybe I just did them on my paper while you were supposed to be working. Well, did you get those?
Yeah.
Do y'all see how I got those?
You did those with me in the morning.
That's what it was. I was like, why do I have stuff written on this paper? Thanks, man.
You're welcome.
Good looking out. All right, so on number 4, that should be 103. So that becomes 10 root 3. And that's how you say this. You say 10 root 3 or 10 times the square root of 3. Does everybody see how I got those? Do we need to walk through them again, or are we okay? Are we sure? Okay. Number next would be 36 and 10. So that's 6 root 10. Yes, no, maybe. Number 6 would be 49 and 2. So that's 7 root 2. Are you not grading his paper right?
No, she's saying I got it wrong and I got it right. She's 10.
I made a mistake. I'm human. Calm down.
All right, so for number 7, I got 81 and 2. So I got 9 root 2. And number 8, this is where it becomes fun. Do you have a question? Julia, do you have a question? You're just looking at me? See my beautiful face? I know. Alright, so for this one, you get 64 and 3, and then you take the square root of it. With the number on the outside, you would do 4 times 8, and you'd get 32. So it's 32 root 3. Is anybody alive out there? Do we understand what's going on? Alright, so for number 9, I got 49 and 6, correct?
Yeah.
And that gives you negative 14 root 6. And number 10, I got, what's the square root of 49, guys?
7.
What's 7 times negative 2? Is our mind blown? Do we not understand? Like, what's happening? Oh, okay. So maybe we should pay attention to what's happening before we come at me? I'm just kidding. I'm excited. Alright, so for this one, I got 16 and 7. And then when you bring that, that becomes 20 root 7. Because the square root of 16 is 4. 4 times 5 is 20. Yes, no, maybe. Okay. Yes, ma'am. Oh, who's Miss Asbury? I'm just used to you yelling my name and needing me.
She said never mind.
Are you sure? Do we have any questions? Are there any we need to go over?
No.
Are we sure? All right, count up their check marks. Multiply it by 2. Tell me the grade. No, they're going to tell me their grade. Let's see where I'm moving it. Once you, hang on a second. Once you break it down like this, and you take the square root of 64 and you get 8, you would do 4 times 8 and get 32. So when there's a number on the outside, after you break down the inside, you multiply. Every time. That's it. Yes, ma'am. Do you need me to zoom in some more?
Story of my life.
Which one, baby?
8.
8? Okay. You see how we got 64? and 3. And then we took the square root of 64 and we got 8. And then we did 4 times 8 and that's how we got 32. Why?
Because it says
That's what you were saying to me.
the receipt,
But-
the whole receipt. So all 4.
So why didn't you come up here and write that down? You were just saying it's 4S, and I was pointing at that one, and I was like, I know that's 4S.
No, because all the other problems we've done have been like with the numbers and then just S plus D equals whatever. That's how I would have done it. But no.
You what? You wouldn't have made me mad if you would have told me.
No, we
Stop that now.
No, we were trying to figure out what was going on. I told my whole class I was trying to figure out this answer. This kid in
Look at
came up
Compton.
with it.
So, same thing, but you see where I said S equals D plus 71? It's 4S equals 9D plus 71 because we have 4 saws and 9 drills.
Because it says the receipts from the saws exceeded the receipts
Yeah.
from the drills.
Oh,
And an individual
Oh!
drill. An individual drill. I know.
That's why I
was mad
keep
at
you
myself for
around.
that. Well, no, I didn't figure it out before. This kid told me something in third I didn't understand. I had to think it through.
2 points.
Are these called perfect square roots?
Yes.
Okay.
Okay. Do we understand now this? Yes.
Can I see something about the dollar here?
Yes.
So,
The one we were just talking about?
yeah.
Okay.
Like, what's the
It says the receipts from the saws. The receipts, we sold 4 of them. It's not asking just the saws.
Okay.
It's the receipts at the end of the day. So it's 4S and 9D, which is what Alex was trying to tell me, but he just kept saying it's 4S, it's 4S, and I was like, I know it's 4S. And he didn't tell me which one over there. I wouldn't have been angry, I swear. Not at you, I'd have been angry at myself for not catching it. I don't know why y'all are so afraid of me. Alright.
I don't know why y'all are so afraid of me when y'all are talking about murdering people. Right, and how to do it, and you pop them up and then put them in the lake.
Alright. So what if okay, before I do this next part, do we have any questions on 1 through 10? Because you have to tell me now. Are you sure?
Positive.
Okay, now what if I told you that I wanted to take the square root, and I don't want you to write this down, I just want everybody to watch, the square root of 16x to the 6th.
I'll break down 16.
Okay, what would we break down 16 into?
4.
So that would become 4. Now what would we do with this x to the 6th?
You break it down to X.
Into 3, right? Okay, so we have 3 and 3. Oh, should put an x. And so we have 2 of those, right?
Yes.
So what do we bring to the outside?
One of those.
One of them. Boom, you're done.
Because it's an odd. Wait. Why is it
Now, the reason is, how many x's do I have?
6?
So 1, 2, 3, 4, 5, 6, right?
Oh.
It's the square root. So how many of each thing do I need? It's the square root, so I need 2. So I have 2, 2. You held up 3 fingers. 2.
Okay.
So how many of the sets do we have? We have 3. So that's where it becomes x cubed. Alright, so what if I said the square root of a to the 9th, b to the 7th? Now first let's talk about a to the 9th. This is an invisible 2. How many times does 2 go into 9?
4. 4 times.
4 times with how many left over? 1 left over. So it would be a to the 4th, and then we'd have a under here. How many times does 2 go into 7?
3 times.
With how many left over?
1.
That's it.
Wow, it's okay. We did that yesterday.
We did.
But
I'm just reviewing it again to make sure. But what?
we're not there yet. I was going to talk about number 11.
We're not there yet. So what if I said this? What kind of exponent is this? And it starts with an R.
Rational.
Rational. Okay? So if I wanted you to convert this from a rational exponent to a radical, what would we do? We can use our, huh?
Say that again.
I want you to convert from a rational exponent to a radical.
You bring the 2 on the outside. Take it over.
Now, remember, I go from here to here. Because remember, we talked yesterday in our notes, we said that if this is not written, it's understood as a what? A 2. So we have in our notes, it was the first foldable, or first doodle that we put down. We said I and E, E and I, right? Our exponent is on top, our index is on the bottom. And index goes here, exponent goes here. We did this yesterday and the day before. So if I'm asking you to convert from this to this, your index or your denominator goes over here, your numerator goes here. So what if I said, $25 to the 2/3 power?
The 3 was on the outside, and then and then 25.
You can do it like that.
The 2 is on the outside of the front, right?
Yeah.
Do you still put the 1 like the bottom one?
So, yes, the bottom number always goes in the mullet. This is a rational exponent, and we're going to radical form. What if I said vice versa? What if I said I wanted you to convert this from a radical to a rational exponent?
It would be 17.
To the 1/2. Why is it 1/2?
Because the 2 is in the mullet, and the 1 is in the...
Fantastic. All right, so we ready for one more
Yes.
before we go on?
C.
What if I said that I wanted you to break down if I wanted you to break down boxes? I'd rather you not break down boxes in math class. Maybe one day.
It's my dream.
Maybe we'll make boxes and we have to go to the
We will be packing. Yes, we're all going to help pack. All right, what if I said the cubed root of 16?
Then it'll be 3 over 1.
16 to the 1/3, right? And what if I said I wanted you to break this down?
It'll be 4.
2.
What's our index? So how many of the number do we need? 3 this time. So the reason we did perfect squares before was because we had a square root. But if we have 3, we need 3 of the same number. So what can we break this down into?
5 and the remainder 1. 3 times 5 is 6.
Break this down. Just 4 and 4, right? Okay, do we have 3 of the same number yet? So can we break down our 4s more?
Oh, okay.
All right, do we have the number of 2s that we need? We need 3, right? Okay, so we would bring that to the outside. We have 1 left over, so what happens to him? So 2 cubed root 2. Yes, you have to. Otherwise it would be square root. And that's 2 different problems. So the square root of 16 is 4, right? That is not the same thing as this. At all, in any way, shape, or form. Because you need 3 of the same number. This is a cubed root. Just the same way that 4 squared is not the same as 4 cubed. So your index changes things. Are we ready for 11 now? Now that we've talked about that. Yes.
So you know like how you said there's nothing out there, it's going to be a 2?
Yes.
There'll always be a 3 out there? If it's cubed?
If it's cubed, there will always be a 3. If it's to the 4th root, there would be a 4. If it's to the baby Jesus root, there would be a baby Jesus.
So that goes, when it does that to 2?
I'm sorry?
Can you put that back in?
I will. I'm going to. What are you saying, Kalia?
So it's just not out there when it's squared.
Correct. It's just not out there when it's squared. All right. What part am I putting back up?
What did you just-
This?
Where'd you get that 3 from?
This?
No,
Uh,
over here.
From here.
Alright, just making sure.
So you write it with a problem. Now that is number 11. So we're trying to simplify it. We're trying to put it in simplest radical form is what it's asking us. So simplest radical form means we can't break it down any further. So it has cubed root. That means we need 3 of the same number. We just did that. We said 4 and 4. We broke this down into 2 and 2. We have 1, 2, 3 2's. So that becomes 2 cubed root of 2. You have to write the cube. Does everybody understand?
You have to write
The 3, the index, the cube, yeah. Does everybody understand?
Yes.
Are we sure? Okay, now let's look at 40. Are you ready to look at 40? 12, the cubed root of 40, the next problem. All right, what can we break down 40 into? 10 and 4, okay? So if we do 10 and 4, we need how many of the same number?
3.
We need 3 of the same number. So what can we break 4 down into?
2. And then break it into 5. Oh, no.
Break this into 5 and 2. How many 2's do we have?
3.
So how many are going to go on the outside? 1. And then what stays under?
5.
So 2 cubed root 5. We on the same page? Are we sure? Okay, so let's write that up here. Let's make sure we write our answer in our box. Can you do 13, 14, and 15 without me? Maybe 16? All right, talk about it in your group. You're going to have 8 minutes. I'm going to put a timer up for you.
Is this homework?
No, this is right now.
I don't know what I don't know.
You don't know what you don't know? It happens. Okay, so remember, when we're doing these, we need 3 of the same numbers. So I'm going to rewrite this guy on a separate piece of paper so that I can actually see him. We're trying to do the cubed root of 135. So we're going to break that down by what? What did you guys pick to do? 25 and 3? 45 and 3? Okay, so then you got 9 and 5, right? Now, we can't break 5 down by anything else. It's a prime number. So we're going to break this down into 3's. Then we have 1, 2, 3 3's. And what's left over? 5. So that 3 comes to the outside. Cubed root 5.
You can't see it.
Yeah. Yes. As long as there's 3 of them, yeah. All right. The next one is the cubed root of 243. So I'm going to break that down into what? What did you guys choose?
81 and 3.
Okay, so if we do that, then that's going to be 9 and 9. But we need 3 of the same number, right? So I'm going to choose to break this guy down into 3's. And then I have 1, 2, 3. Yeah. Yeah. And so then that becomes 3 cubed root 9.
Wait, do you see it?
I feel like the 3s are easier than the 2s.
Because with these, you're just breaking it down by multiples. On the 2's, you're needing a perfect square. So that makes you think about what number you can use. On these, you can use any. That's good though, right?
It's easy, you just gotta work it out very,
Methodically?
yeah.
Yep. Alright, so then cubed root of 320. 32 and 10? Okay, so then did you break this down into 2 and 5?
Yes.
And then what did you break this into?
8 and 8 and 4.
8 and 4. Okay, so then this is into 2 and 2. But then this is into 4 and 2, which is 2 and 2. So then from there, you have, grab the same color. You have 1, 2, 3 of those, right? And then you have another 3 of those, right? So you would bring one of these and one of these. What's 2 times 2? Okay, so it would be 4 cubed root, and then that 5's left over. Is there an easier way? Did somebody choose different numbers? 20 and 16? Okay, so if you did 20 and 16, you have 4 and 4, and then you have 4 and 5. And then boom, 1, 2, 3. Yes. I think I meant that you needed to grab another one.
So if you already have 3 4s,
Then stop and take those. Because you just need 3. Unless you can break this other number down. And we can't with 5 because it's prime. Alright. Are we ready for the last one? The cubed root of 375. Thank you. Okay. 375 is $3.75. It's how you can look at stuff like that. And you know a quarter is going to go into that. So I would do 25 and what, 15?
Yes.
Okay. Then that's 5 and 3. That's 5 and 5. 5, Blair. So then it's 5 cubed root 3. Magic! Questions? Are we sure? No homework tonight.
thank you so much.
You're welcome.
And Asbury,
Yo.
did you ever get